Hi guys, welcome back to another video about different data set. Today I'm gonna work with life expectancy. So I have data for all the countries. So we're gonna predict life expectancy based on the input features. So we are going to work about how to load the data set. So this is like end to end. I had already worked on a linear regression machine learning model, but in this video, so if I have a problem statement, what are all the steps I need to follow from starting from collecting the data, like collecting the data and then loading the data set based on the type of the data set. For example, if it is a CSV file, Excel file, or sometimes we need to integrate it from with a few other tools like SQL or from the website also from through the hyperlink. So we can import the data from lot of many ways. So here I am gonna import the downloaded data set which is in CSV file. So and also we are gonna work on exploratory data analysis, like what is my data set, what are all the features. Give me a minute. Okay, then we will go ahead and start working on data cleaning. Like, is there any null values and how these are affecting my features? Like, do I need to replace the null values with anything, or is it good to remove null value, something like that? We're gonna work on data cleaning as well as pre-processing. Pre-processing, nothing but so like converting categorical variables to numerical, like with one hot encoder, or and if I wanted to do some scaling, like different columns will be in different units or different values, right? So we need to make all the features into one line by doing the standard scalar. So we need to do that as well. Once we're done with, we need to do some feature engineering and we need to select the relevant features. What are all the features and how these features are impacting my target variable. Here my target variable is life expectancy. How many years a person from individual country they are living based on the some data we have. So that is we're gonna predict. So that is my task today, that is my problem statement. So here you can see the problem statement. So here we can see the problem statement is like using the life expectancy data set. I have imported or I have collected this data set from Kaggle, and we aim to build a regression model to predict life expectancy based on various health, economic, and social factors. So that is about the data set. So we will have a better look at the data set once we load it. So in the next step, I'm going to import all the necessary libraries along with the importing the data set, and also we're going to inspect. So I'm using pandas for manipulation. If I wanted to do any exploratory data analysis, I have to use pandas and numpy for any mathematical computations. And if I wanted to visualize anything, I have to use matplotlib. So I imported Seaborn for advanced visualizations, and I wanted to split the data set into training and testing, and that is why I have imported train test split, and also I'm importing linear regression model because my target variable is a continuous variable. So that is why I'm gonna use a linear regression. And if I wanted to evaluate my model, so that is why I'm using absolute mean error and mean squared error, so that I can able to evaluate my model, how good the model is behaving and how good the model was trained. So I'm just importing this warning so that I don't want to see any further warnings in the video. So I'm setting these options to see maximum columns and maximum rows. I don't want to see any hidden rows and columns. So this is how, let me run this. I'm able to run all these libraries. So now this is my data set. It was located in my internal repository and in my system. So I have reading pd dot read, since it is a csv file dot csv file, so I need to use pd dot read csv and then this link of the excel file. So let me run it. And let me see the head of the data. So this is my data set, how it look likes, the head of the data set. So we have a country column with the country name and the respective years, and the status of the country, whether it is a poor country, rich country, developing country, something like that. So for Afghanistan, it is the status is updated as developing, and life expectancy. We are gonna work on this feature. So sorry, this target variable. So here it is showing as of 2015, there is a 65 years, the average life expectancy of Afghan people. And for 2014, it is 59.9, and 13 it is 59.9, but it got increased in 2015. So and adult morality. So these are all the features which are impacting this life expectancy, like adult morality, infect deaths, alcohol, and percentage expenditure, hospitals. Because if there are any hospitals, then we can able to again people they can live healthy, right? If they have infected with any disease or something like that, if we have a lot of hospitals, then we can able to cure. And BMI, body mass index, under 5 deaths, how many deaths are there an year, and polio, total expenditure, and HIV/AIDS, and the GDP, population. So there are some features which are impacting my target variable, which is life expectancy. So this is my data set. So we are gonna work on this life expectancy, and these are all my features. So let me have a look at my total columns here. So I have these many columns, and I need to look at the correlation, right? So if I wanted to look a list of columns, so this is the command pd dot columns to list. It will give me a list of columns. And before this is like part of EDA, exploratory data analysis, we must look at the correlation, how my target variable is correlated with other features. So here df.corr will give me the correlation among all the columns. So I'm gonna plot a heat map, because df.corr will just give me a table table with these values. But if I use heat map, it will give me a nice idea with some coloring part. So one being perfectly correlated, and zero being there is no correlation, something like that, -1. So here you can see these are all my columns, and so this is my target variable and how it got correlated with the other columns. So here you can see this is my target variable. It has very highly correlated with income, composition of resources, and also thinness 1 to 19, population very less correlated, GDP it has a high correlation, HIV/AIDS also correlation is there, and this also the total expenditure. There is a less relation. Folio we have around 47% of the correlation, under 5 deaths 22%, and BMI 57%, and measles 16%. So this is how my all the other input features are highly correlated. So basically the income composition of resources, which is highly correlated of 72%, and schooling is impacting 75 percentage of it's correlated with the life expectancy. The person who is educated, they are less like, I mean, more likely to, I mean, the data shows it practically it may be right or wrong, but as per the data set we are working, it is having a 75 percentage of the correlation with the life expectancy, my target variable. So this is how you can look at all the correlated input features, so that you can able to in feature engineering you can able to select all the related features which are highly correlated. If I wanted to drop any column, if that is not gonna impact my model, then that is okay. So that is how you can, this correlation heat map will help us to choose the right features to build the model. So that is about how the correlation among the columns. And now we need to handle some missing values without impacting the model. For example, so df.info will give me the information about all the columns with a number of entries, and as well as the data type of my column. So here you can see total entries are, here you can see the total entries 2938. So there are any null values in country, year, status, life expectancy, something like that. But there are few null values in alcohol column, and also we have few null values in hepatitis. So there are some null values. We are gonna, I mean, handle these missing values, whether to reject it or whether to replace these null values with a mode or mean without impacting the skewness of the data. And also you can see here the data types of the individual columns. So my life expectancy column, which is in float, which is a continuous variable. So that is the reason why the best machine learning model to predict a continuous variable is a linear regression. So that is why we are gonna uh, train a linear regression model to predict life expectancy of different countries. And so this is about, and now we need to do some feature engineering. So step by step procedure: first loading the important libraries, and also next reading the data, then looking at our exploratory data analysis and what are all the features, what are all the columns, how they are correlated, is there any missing values, if I have any missing values, how to handle it. So we are going to work all these things. Next, feature engineering. Features nothing but all the input features which are impacting my target variable, like y is equal to mx plus c. Y is my target variable and it is a dependent variable, and x is like my features which are independent features. So here, year, adult, morality, these are all independent, they are not depend on any factor. So as per the data set, these are all the independent features here. In fact, I mean, that's alcohol, percentage expenditure, all these things. So that is why I am putting all these features in x, like my input features are this, and my y is dependent on all these input features. If there is any change in year, adult, morality, and alcohol, something like that, it's going to affect my output variable, which is life expectancy. if p if a person is taking more alcohol, then it's going to impact his life expectancy. A person who is diagnosed with HIV/AIDS is gonna, I mean, there is an impact with the life expectancy of that particular person. And also which has income also, which rich people, they can I mean, they can have nice healthy lifestyle. So that is what, these are all the features will affect the target variable. Now I need to select relevant features I have selected. So now I am dropping if there are any null values, so that it will not impact my model. So df dot select, I have select, and this is my entire data set including my features and the output variable, which is life expectancy. Now df dot drop in will drop all the null values. Now I'm splitting the data set and x and y, because I'm gonna prepare a linear regression model, which is a linear line. X is equal to y is equal to mx plus c. Now I need to split the data into input features, which is x, and my target variable, which is y. Here, all these features are under my input features. So I am assigning it to x, and y is my target variable, which is life expectancy, x and y. So now I need to convert if there are any uh, non-numeric values, so that it's not gonna impact my performance of the model. So that is why I'm applying this pd dot to numeric, and if there are any errors occurs, then I'm gonna ignore it. So now I'm handling, after after doing this feature engineering, if there are any still null values, now I need to fill those values with a 0. So that is how we can handle remaining NaN values after the conversion. So this is conversion, like it is like scaling, standard scaling. I can say it is one hot encoder because I'm converting my like if there are any object or categorical columns, it has to be converted into numeric. So here I got converted, and if there are any errors, so I'm gonna work on it. And if there are any null values even after conversion, I need to fill it with a 0. So that is about X and Y feature engineering. And now scaling part. Now I am importing standard scalar to scale. Here we just converted categorical to numerical, that is part of encoding. And here I need to do some scaling part, because my each and every input features are in different scale. Like adult mortality is 263, this deaths are nothing but number of deaths, but this alcohol is 0.01, which is a different, in a different scale, and this is in a different scale. I need to make all these features in a single scale, so that we can able to build a proper model. So that is why we need to do this standard scalar. And importing standard scalar from pre-processing. Scalar is equal standard scalar, and now x scaled I need to I need to pass these features here, so that if there are any, like all the input features with a different scaling, it has to be converted into one line of scaling. So that is how we did a standard scalar to scale the features. And now I need to import train test split. Now I'm done with importing the data, I'm done with handling the missing values, I'm done with feature engineering, and also I'm done with one hot encoding or converting the categorical columns into numerical values. And also I'm done with scaling. And also now we are ready to build a model. So before building or before training a model, we need to divide the data set. If I take my entire data set has 100%, so I need to divide the entire data set into a training data set and a testing data set. So that I need to train the model with the training data set, so that the machine will able to understand how the data is there, how the input features are impacting the target variable, which is life expectancy. So that machine will come to a conclusion. Based on this input features, the output is updated, or output is impacting. So that if I pass the remaining training set, then machine gonna predict the values. So that is what I'm importing train test split from the sklearn.model selection. So I'm gonna use xtrain, xtest, ytrain, ytest, train test split. So I need to pass my uh, features and target variable, and I'm giving test size is 20%, because I'm gonna test 20% of the data, and 80% I'm using for training. Random state I'm giving 42. Now I need to select a random, sorry, model selection. So I can able to use only linear regression, but I just wanted to look at all the regression algorithms. Like we do have random forest regressor and also support vector regression. So I'm gonna see how the other models are training, like which is giving me accurate results. So that is why I'm importing all the other regression models also. So first I'm importing linear regression from linear model, and a random forest regressor from ensemble, and I'm importing my support vector regressor from SVM, and I need to evaluate my model. So that is why I'm importing absolute error and mean squared error. So now I'm giving, since I'm using three models, so linear regression is linear regression, random forest is random forest, and support vector machines SVR. I imported models. Now I need to train the machine with the three algorithms. So name comma model, because my model is this in models items. So model dot fit x train and y train. So training data, input features and target variable. Training data I have feeded to the model, so that the machine will be trained. And y predictions also model dot predict. I am gonna pass this testing data set, which is I kept 20 side asset, right, to test the model. So that my means absolute error, mean squared error, by passing the testing data set and also the predicted I got the results here. And I also have the 20 percentage of my testing data set for main absolute error and mean squared error, and this is RMSE. So these are all my results. So with the linear regression, so my mean absolute error I'm getting 2.8, and root mean square I'm getting 3.6. So random forest, it is giving me 1.11. RMSE I'm getting 1.89. Support vectors I'm getting 2.14, and RMSE 3.10. So with this data, I can able to conclude that random forest, which is giving me nice results, because wherever I'm getting a less RMSE or less mean absolute error, that means that particular model is trained well and giving me good results. So the my random forest model will, which is trained well and which is giving me good results. So now I wanted to look at the actual versus predicted. So here you can see a nice regression line, and so I'm imported, say I'm using scatter plot of actual versus predicted. We have, I mean, we got actual values which are nothing but a y test and predicted values y pred. So I wanted to plot a regression line with the actual versus predicted. So these are all my actual life expectancy which is there in the data set, and these are all the values which machine predicted. So this is a very nice straight line. We can able to fit a perfect regression line. That means model is trained well. So this is how you can able to see how the actual values and how the predicted values, how machine is evaluated or how machine is trained. This is how you can see predicted versus actual values. And here one more part I also included, feature importance visualization. Just like which feature is impacting the target variable, just like correlation, but here you cannot get how much percentage which is impacting. Here you can see percentage wise you can see, but here you can have a very nice idea with a bar plot. So here you can see how the feature importances in predicting life expectancy. So this is how you can plot feature importance visualizations. So that is about the data set. Like it is a very good data set, and life expectancy of different countries, and we have already, we need to predict it based on the data. So I just worked on all the steps, step by step procedure in this tutorial, like importing libraries to visualizing the predicted versus actual and also the perfect linear regression line. So I hope it is a step by step tutorial for linear regression for life expectancy. I hope, I think it's interesting and also a step-by-step process. So if you really like this video, please click on the like button. So if you are really enjoying or if you are getting something out of all these videos, please do subscribe the channel. Thanks everyone. Bye. See you in another video.